Hello students, I hope everyone is fine. So today we are going to start a new topic which is called as complex numbers. So before going to discuss in detail about complex numbers, so we have to learn what is the evolution of these complex numbers. When we are already learning these real numbers, rational numbers, all these number sets, number system, why we have to go for another number system? So let us discuss in detail about the introduction or evolution of this complex numbers. First of all, whenever you are solving any equation, especially quadratic equation, like example x square plus 1 equals to 0. In this case, when you want to find out the solution for x, so you will come across a situation where x is equals to square root of minus 1. Now, what could be the value of square root of minus 1? So, there is a question mark. How to calculate the square root of a negative number? So, this leads to an idea that mathematicians has to go for extension of these real numbers along with the negative numbers under square root. So, the solution here is not a real number. To define this one, to know the x value, they have to go for another number system which is called as complex numbers, which contains real numbers along with square root of negative numbers. But how to find out the square root of minus 1? So they generalize, they have come with a solution that square root of minus 1, a negative number, could be something which is called as imaginary number. So here that number is denoted by I. Here I is called as iota, which is a Greek word. Okay, well and good. Up to here we have defined iota, x is equals to y, solution we got. So whenever we have a number under square root, negative number, so we can write it as square root of minus 4 can be written as, since it is having minus, I can write it as, I can split it as minus square root of minus 1 into 4, that is nothing but square root of minus 1 into square root of 4. Square root of minus 1 nothing but I, and square root of 4 is 2. I2 or 2i we can write. But in some cases, like square root of 36, how to find out the square root of 36? Since it is a positive number, it can be written as 6. But we have a rule that just now we have discussed. Square root of AB can be written as square root A into square root B, where the condition is that, very important condition, either of them should be, that means at least one among them should be non-negative. That means both cannot be negative at the same time. At least one is negative and the other one is positive. So there could be a possibility for mistake that square root of 36 can be written as square root of minus 4 into square root of minus 9. See, if I don't follow the condition of that square root of A into square root of B, where both are not negative, any one is negative there. So I can write it as 2i, 3i. 2 into 3, 6. I square. What's the meaning of I square? I square is nothing but minus 1. So minus 6. But actually what is the square root of 36? 6. So it leads to a negative answer because we have not followed this condition here. Are you getting me? So square root of A and square root of B, anyone should be anyone. That means at least one should be non-negative. So very important condition. So let us elaborate the iota imaginary number in detail. So whenever we get a iota in terms of powers, so how to define its values? Just now we got I square value. Similarly, I can get I cube, I power 4 and so on. We know that I is equals to square root of minus 1. I square is equals to minus 1. I cube can be written as I square into I. Where is I square nothing but minus 1? So it leads to the value of minus I. I power 4. I power 4 nothing but I square whole square. That means minus 1 whole square. It can be written as 1. So here we have to remember that not only I power 4, for all the I power of 4 multiples, we are going to get 1. That means if it is I power 8, I power 12, I power 20, so all 4 multiples we are going to get 1. So what happens if it is more than 4? So it can be written as I power 4 plus 1, where I power 4 into I power 1, I can write I power 4 value, I power 4 value 1 into I. So that is nothing but I. So not only this one, whenever you are getting I power as n, now what you have to do is split that n number in the form of 4q plus r using the division algorithm. If I can able to write that number as 4q plus r, that means I power 4q plus r. Just now I said that for all the I power 4, that means 4 multiples, so the value is going to be 1. So I power r. That means, so whenever you are getting the number as I power n, we are splitting in the form of I power 4q plus r, I can write it as I power r. So let us take an example. I power 135. So 135 I can split it as 4 3s are 12 and again 4 3s are 12. How much? 3 will be left. 4 3s are 12 and 4 3s are 12. So 4 multiple I power 4 into 33 into I cube. So what is the value of this one? 1. I cube. What is I cube value? Already we know. Minus I. So minus I is going to be the I power 135 value. So not only this one, if I take another example where I power 1 by I power 47. So I can write it as 1 by I power 4 into 11 plus 3. That equals to, since it is a 4 multiple, I can write it as 1 into I cube. So I cube value is nothing but minus I. So when you convert into as a rational number, so multiply with I and I. So I by minus I square. But what is minus I square value? Minus 1. Minus 1 into minus plus. That means I is going to be the value of 1 by I power 47. So let us solve some problems which are written on the board. First one, find the value of I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3 for all n belongs to capital N. That means the power should be, the n value should be natural number. So if you look at the each and every term in the expression, so what is the common thing you are observing? You are observing I power n as common. I power n. So if I take out I power n common, so what is left inside? 1, and here I square, and here I cube. Next, I power n 1 plus I. We know that I square value is minus 1. Here minus I. So I power n, you are going to get 1 plus I minus 1 minus I. So I minus I 0, 1 minus 1 0. So I power n into 0, 0 into anything, 0 is the answer. So this problem has been solved. Let us look at the second question, second problem. Ix square minus 3x minus 2y. So either by so here to know the x value, so let us find out this with the quadratic formula. What is b here? Minus 3. So minus of minus 3 plus 3 plus or minus square root of b square. B square nothing but minus 3 whole square, 9 minus 4. A value I, C value minus 2y by 2y. 3 plus or minus square root of 9 minus I into I square, that is nothing but minus 1. Here minus into minus plus. So again plus into minus minus. So 4 2s are 8 by 2y. So we are going to 3 plus or minus 1 by 2y. That is nothing but 4 by 2y or 2 by 2y. So on simplification we will get 2 by I or 1 by I. So here 1 by I can be, when you rationalize this one, so it will be converted into minus I. Similarly here minus 2y. So what are the roots of this? What are the values of x? Minus 2y or minus I. So second problem is also simplified. If you look at the third one, third solution. So I power 592 plus I power 590 plus I power 588 plus I power 586 plus I power 84. Similarly, we are having some other expression in the denominator. But if you look at the compare each and every term, first term, second term, there is a difference of 10 powers. So what I will do here is I will take out I power 10 as a common from the numerator side. So then I will get I power 582, I power 580 plus I power 578, I power 576, I power 574 divided by 582, I power 580, I power 572, I power 576, I power 574 and minus 1. So this entire expression gets cancelled, simplified, you will get only I power 10 and don't forget minus 1. So I power 10 can be written as I square whole power 5 minus 1. I square value minus 1. So negative power minus 1. So minus 1 minus 1. So minus 2 will be the answer. So in all these three problems, we have seen the simplification of iota, that means integral powers of iota. But when you come to the fourth question, x square minus 2x plus 10 equals to 0. Same, x is equals to minus b, minus half minus b, plus or minus square root of b square minus 4ac by 2a. So 2 plus or minus square root of 4 minus 410, 40 by 2. 2 plus or minus square root of minus 36 by 2. So 2 plus or minus 6i by 2. 2 is common here. 1 plus or minus 3i by 2. 2 gets cancelled. We will left with 1 plus 3i and 1 minus 3i. So far, we used to get only a single term which is 3i, 2i or single I or minus I, this kind of terms. But here we got 1 plus 3i, 1 minus 3i. So this is the complex numbers general form. So that means the general form of complex numbers will look like this. So what is complex number? Just now we have defined. So the number which is in the form of a plus ib. So this a plus ib is denoted by small z. So this is the complex number general form, where a is called as the real part of imaginary, real part of the complex number, and here this is the imaginary part. B is called as the imaginary part, and IB is called as the imaginary number. Don't forget, don't confuse. So now this complex number is also thought of as a order pair, a comma b. That means we can represent this complex number on the plane. This plane is called as complex plane. So generally we have an idea of coordinate plane. So because we are representing the complex numbers, we are calling it as complex plane. So before going to that complex plane, so let us discuss some more things regarding these complex numbers. If b is equals to 0, then z is equals to a will get. So then it is called as purely real number. Purely real number. If a is equals to 0, we will get z is equals to ib, where we will get purely imaginary number. Purely imaginary number. Next, we can say that real number set is the subset of complex numbers. Real number set is the subset of complex number. So complex number will be the superior. So complex number is the superset of real numbers. That is of all the numbers. Now complex plane. So in this complex plane, so we have x-axis as well as y-axis. This horizontal axis is called as a real axis, and this vertical axis is called as the imaginary axis. Imaginary axis. So generally whatever the numbers we are going to represent on the number line, we are going to represent on the real axis, on the right side positive, on the left side negative. Next, on a vertical imaginary axis, so we'll take I, 2i, 3i, 4i. Here minus I, minus 2i, minus 3i, minus 4i. Suppose if I want to represent any number, here take the, already I told you I can represent a complex number as an order pair. So a comma b. Suppose if it is representing 4 comma 2i. So this is nothing but 4 plus 2i. Similarly, if I represent any number here, so this is called as minus 2 comma I, but it is called as minus 2 plus I, complex number. And if I represent any number here, this is the point minus 3 comma minus 3i. So this is nothing but minus 3 minus 3i, complex number. If I represent 5 comma minus 3i, so this is nothing but 5 minus 3i. So this is the representation of complex numbers on a complex plane. This complex plane is also called as Argand plane. Argand plane. Now, two important points we have to discuss here. Two note points. Whenever we multiply any complex number, suppose 4 plus 2i is in the first quadrant, minus 2 plus I is in the second quadrant, minus 3 minus 3i is in the third quadrant, 5 minus 3i is in the fourth quadrant. Suppose if I multiply these complex numbers with the I, another imaginary number, another imaginary number. If I multiply, then this point will be shifting its coordinate. That means this point will change the quadrant. How it will change? It will change by anti-clockwise direction 90 degrees. So suppose 4 plus 2i is taken, multiply with 4i. I into 4, 4i, I into 2i, 2i square. That is nothing but 2i minus 4i minus 2. Nothing but minus 2 plus 4i. So minus 2 plus 4i lies in the second quadrant. That means, so whenever we multiply I with a complex number, that number will shift its quadrant by anti-clockwise direction 90 degrees. Suppose if I multiply with minus I, think that I am multiplying minus 2 plus I. Minus I into minus 2i, 2i, minus I into I, minus I square, 2i minus I square, nothing but minus 1, 2i plus 1. So both are positive. So that means it will change to the first quadrant. No, quite opposite phenomena. So when I multiply with the I, it is changing anti-clockwise direction. Anti-clockwise 90 degrees. But when I multiply with minus I, it is changing clockwise 90 degrees. So that is the shifting of this point when you multiply with the another imaginary number will occur.